Hi, I'm Jane, and this is my partner Tahani.
And our science fair project is biological, chemical, and physical properties of Ponitz CTC water fountains.
Okay, so the abstract. Water is essential for all living things to survive, but yet not all water is the same. The water that is being consumed every day have large amounts of toxic chemicals, which may or may not have been placed there on purpose. And then we made an experiment upon its CTC, testing the water fountains for heavy metals and chemicals, including bacteria. Okay, so we tested each one. We tested the pH, we tested fluoride levels, lead levels, ammonia levels, copper levels, chlorine levels, and bacteria percentages.
So this is the introduction, getting into what everything is. pH is just a measure of how basic or acidic something is. A heavy metal is just a metallic element that is poisonous or toxic. Fluoride is a natural material that's released from rocks and it is soaked into the soil, water, and the air. Lead is a natural occurring element that is found in small amounts of the Earth's crust. Ammonia is a chemical compound that's made up of nitrogen and hydrogen. Then copper is a chemical element made up of minerals such as chalcopyrite and bornite. And then chlorine is a mixture of salt water and electricity.
The question was, which drinking water station will have the most heavy metals and bacteria?
So we came up with the hypothesis, which was it was hypothesized that the water in Ponitz will be low in bacteria and heavy metals because the filtration systems are new and have been recently cleaned.
So step one, the question. So in the scientific method, you start asking the question and then you try to perform an experiment to find the answer to that question. So asking the question is wondering what can be if this is done, or like having a question, going after the answer is what science is all about, and the step one of the scientific method.
So step two of the scientific method is doing research. So the more research you have, the better understanding you have of that subject or your topic. Without research, there's no information to go off of for the experiment. Different types of information that can be found is finding old data, finding ongoing studies about the subject, or finding lab reports on the subject. With the proper research, the experiment can go really smoothly.
The step three of the scientific method is forming a hypothesis. A hypothesis is if this happens, then this should happen. It's an educated guess on what will happen based on previous data or what is already known. Scientists constantly make new hypotheses to predict what is right or wrong in order to make sense of the world around them.
So step four is creating a material list. That way you know what you need and the amounts you need. Usually a material list will contain the machine, the make and model, and with any type of substance, it will include how many grams you need.
And then you go to the protocol, is this fifth step in the scientific method. This is how, these are the steps that you follow to plan out and experiment your question and try to find the answer. It will tell you what is needed, when, and how much of each substance was used for the experiment. And we usually write it in past tense because we've already done what we're writing about.
So the sixth step of the scientific method is collecting data. So after the protocol has been completed, then comes collecting data. The data will tell you whether the hypothesis was correct or incorrect. It will also answer the question that was asked at the beginning of the experiment. Most data is put into charts and graphs to get a visualization of the results of the experiment.
Then conclusion and sharing. The final step of the scientific method is to conclude the experiment. The conclusion wraps up everything, restates the question and hypothesis, and then tell us whether we were right or wrong about what we hypothesized. It also summarizes the data and then finishes by sharing the data. And then we post the data and experiments online to get new information about the subject out to the public.
So for our project, this is our material list. We used water samples from each of the water fountains, a hot plate machine, hot plate gloves, 8 250 milliliter flask, a stir bar and a retriever, 8 15 ml conical test tubes, 8 petri dishes, nutrient agar solution, laurea broth, pH meter. We also used whey paper, that's a given, ammonia TNT test tube vials, chlorine TNT test tube vials, an incubator, a spectrophotometer machine, the Hatch Doctor 2800 and 1900.
Then the protocol we collected each water fountain, the sample from each water fountain, and then we measured the pH level of each of the water samples, and then we made 69 milliliters of laurea broth, and then we put 8 milliliters of each into the 8 15 milliliter conical tubes, and then we have 1 milliliter each of water to each conical tube, and then we put the samples into the incubator for 24 hours, and it was set at 37 degrees Celsius. And the 8 petri dishes were disinfected in the microwave for 30 seconds. And then 250 milliliters of the nutrient agar solution was divided into the 8 petri dishes and left to harden. 4 triangular spreaders were sterilized, and 1,000 microliters of each sample was added to each petri dish.
Next, the water samples were then tested for fluoride. 8TNT878 fluoride test vials were used for this experiment, and the instructions on the box were followed to complete the trials. The day after that, the water samples were tested for lead. 8TNT850 lead test vials were used, and the instructions on the box were followed to complete each of the trials. The water samples were tested for chlorine. 866 chlorine vials were used, and the instructions on the box were followed to complete each trial.
And the next thing that was tested for was ammonia. AT&T 850 ammonia test vials were used, and the instructions on the box were followed to complete the 8 trials for this experiment. The next day, the water samples were tested for copper, and the AT&T 860 copper test vials were used, and the instructions on the box were followed to complete it.
So this is our data. For the fluoride testing, we got an average of 1.62 milligrams per liter of fluoride in all the hallways. The highest amount of fluoride was between blue up and yellow up, with a tied score of 2.04 milligrams per liter.
And then the lead, it was 0.44 milligrams per liter of lead on average, and the highest was burgundy, burgundy down, and green apple. Green apple is the highest of all of them, with a 0.353 milligrams per liter.
The ammonia data shows that on average there was 0.02 milligrams per liter between all the hallways, and then the highest one was definitely green down with 0.102 milligrams per liter.
And the chlorine data showed that the average was 0.36 milligrams per liter of chlorine in all the hallways, and the highest was burgundy down with 0.477 milligrams per liter.
With the copper data, it was a little higher than what we expected, but the average was 1.79 milligrams per liter, with the highest at yellow up with 4.728 milligrams per liter.
And then bacteria data, green down had the most, well, blue up had the most, yellow most bacteria, 99%, and then green down had the second highest of 95%.
So in conclusion, the water samples from the water fountains in each of the hallways, top and bottom, were tested for heavy metals, bacteria, and the pH level. The pH level of most of the water samples were basic, with just an average pH of 8.3. The water samples had an average of 1.62 milligrams per liter of fluoride, 0.44 milligrams per liter of lead, 0.02 milligrams per liter of ammonia, 0.36 milligrams per liter of chloride, 1.79 milligrams per liter of copper after all the tests have been completed. There was also a significant amount of bacteria in each water sample, which we really didn't think that it would be that high, considering the water filters and the water fountains completely have been changed. The hypothesis was proven incorrect, and because it was hypothesized that the water samples will contain low amounts of bacteria and heavy metals. However, it was proven incorrect by the result of these experiments. The possible errors that were made were leaving the petri dishes out of the fridge overnight, and future studies would involve researching about bottled water, since so many students drink from plastic bottle water samples. And that's our science fair project.